Welcome to the debate. Right now, millions of people are swallowing capsules packed with, 50 billion live bacteria, just assuming they're planting this healthy garden in their gut. It makes intuitive sense, doesn't it?
Yeah, I mean, it sounds great on paper.
Right. If you have a barren patch of earth, the logical solution is to throw a handful of seeds on it and just wait for something to grow.
Right, but that logic assumes the soil is inherently receptive and that the climate is universally accommodating. It assumes every single seed is just going to, effortlessly take root and flourish.
Which we know isn't always true.
Exactly. Because what if your body doesn't see those bacteria as a friendly garden, but as an invading army?
Exactly. When we apply that simple seed and soil logic to the human microbiome, we are tossing live bacteria into one of the most complex, fiercely competitive, and frankly, highly evolved ecological landscapes on the planet.
Oh, absolutely.
Yet, this basic premise is the foundation of a global commercial probiotic industry valued at tens of billions of dollars. The core assumption driving all of this is that ingesting live microorganisms uniformly confers physiological and immunological health benefits to the human host.
Uniformly being the operative word there.
Right. So today, we're drawing on an extensive review of clinical trial data, advanced genomic sequencing, and global regulatory dossiers to ask, do probiotics actually work? Or are their perceived benefits just the result of marketing-driven hype? I'll be representing the perspective that specific, highly characterized probiotic strains demonstrate reproducible, clinically significant, and proven benefits for targeted health indications.
And I will be taking the contrasting perspective that most probiotic effects are, well, incredibly inconsistent. They are deeply hyperspecific to individual biology and frequently negligible or even actively counterproductive when they're applied broadly across real-world populations.
To start, I think we really have to address the most pervasive fallacy in this entire conversation,
Which is?
treating all probiotics as a single homogeneous entity. I mean, it is scientifically invalid for someone to look at a generic off-the-shelf bottle of bacteria and declare as a blanket statement that probiotics don't work.
Sure.
Efficacy in this field is strictly strain-specific and disease-specific. Two strains of the exact same bacterial species can have completely disparate functional properties.
Well, I agree that specificity matters in a laboratory setting, but how does that actually translate to the real world?
It translates through highly validated therapeutic successes. I mean, when we look at properly characterized strains, the clinical data is undeniable.
Okay, give me an example.
Take Lactobacillus rhamnosus GG, commonly known as LGG. It's backed by over 250 clinical trials. In pediatric populations, comprehensive meta-analysis show that LGG reduces the risk of antibiotic-associated diarrhea from 22.4% down to 12.3%.
That is a significant drop, I'll admit.
It's a massive, highly reproducible clinical outcome that actively keeps kids out of the hospital. Or, consider irritable bowel syndrome, a condition that severely impacts quality of life.
Right.
The strain Bifidobacterium longum 35624 has been shown to significantly reduce IBS severity scores. In trials, patients dropped from an average score of 303 down to 208 on the standard IBS-SS scale. That represents a tangible alleviation of bloating, distension, and abdominal pain. So dismissing probiotics entirely just because generic retail blends fail, it means we're completely ignoring these targeted, evidence-based successes.
I don't dismiss the controlled trial data for those highly specific, isolated strains. The data is real. I'll give you that.
But
But the broad empiric application of probiotics, which, let's be honest, is how 99% of consumers and frankly many clinicians use them, is fundamentally flawed. And it's flawed because it relies on a completely false biological assumption.
the assumption being?
The assumption of universal gut colonization. For decades, the medical and commercial communities just assumed that if someone swallowed a probiotic and we subsequently detected it in their stool, it meant the bacteria had successfully colonized their gut.
which, to be fair, makes sense on a surface level. If it goes in and comes out, it was in the system.
Exactly. But detecting it in the waste doesn't tell you what it actually did to the tissue. That entire assumption was completely dismantled by the landmark 2018 cell study led by Iran Elenev and his team.
Ah, yes, the LNO study.
Right. They realized that stool samples are just a proxy, and a pretty poor one at that. So they didn't just look at stool. They used invasive endoscopic sampling, literally going in and taking biopsies of the human gastrointestinal mucosa, mapping the gut from the inside.
Wait, they actually took biopsies of the healthy volunteers?
Yes. And what they proved is that humans biologically bifurcate into two distinct groups. They called them persisters and resistors.
Okay.
In the persisters, the probiotics actually engraft in the tissue and set up shop. But in the resistors,
Ah,
the host's native microbiome and mucosal immune system actively mount a defense and expel the foreign bacteria entirely.
so the body is essentially treating the supposedly beneficial probiotic like a pathogen.
Precisely. The native ecosystem says, I don't care that this says healthy on the bottle. You don't belong here. And here is the real problem. Predicting whether a patient is a persister or a resistor isn't something you can do by just looking at them.
Right. You need a functional assay.
You need incredibly complex transcriptomic profiling. You have to look at the patient's baseline microbiome and measure exactly which host genes are being turned on or off in their gut. Because we do not do this in standard medical practice, standard over-the-counter use is largely an illusion of efficacy.
I see.
When you apply a probiotic to the general population, half the people are just flushing it away. It severely dilutes any true biological signal.
I see the biological challenge there. I do. But I think we need to rethink how we define efficacy. I mean, the premise of the cell study is fascinating, but we don't necessarily need permanent mucosal engraftment to achieve clinical symptom relief.
You don't think they need to stick around to work?
Not always, no. We can look at macro-level clinical outcomes, regardless of whether the bacteria set up permanent residence. Let's look at pediatric colic.
Okay.
We have network meta-analyses showing that Lactobacillus reuteri, DSM 17938, literally halves crying time in breastfed infants with colic, dropping it from an average of 116 minutes a day to 55 minutes.
Which is huge for the parents, obviously.
It's a life-changing metric for a struggling parent. And the crucial point here is that this relief happens even if the bacteria only pass transiently through the infant's gut.
But physiologically, how does transient passage explain a durable biological effect? If the bacteria are just sliding over the mucosa and being expelled, aren't they just passing through inertly?
Not at all, and this is where the mechanism of action is so important. Even transient passage yields profound biological benefits through the production of metabolites, specifically short-chain fatty acids, or SCFAs, like butyrate.
Right, butyrate.
Yeah. As these live bacteria move through the gastrointestinal tract, they are metabolically active. They ferment dietary fibers and secrete butyrate. That butyrate then serves as the primary energy source for the host's colonocytes, the cells lining the colon.
Sure, I don't dispute the biochemistry of butyrate.
And this metabolic output lowers the luminal pH, creating a highly acidic, hostile environment for opportunistic pathogens. It also actively reinforces the tight junctions of the intestinal epithelial barrier, preventing leaky gut.
Okay.
To use an analogy, they don't have to build a permanent house in your gut to do the maintenance work while they walk through the neighborhood.
The neighborhood maintenance metaphor is great, but we have to look at the sheer inconsistency of those transient effects. Detecting a transient metabolic output is highly variable.
Well, biology is variable.
True, but it depends on what the patient ate that day, what their baseline inflammation levels are, and what their native flora looks like. When you look at large mixed-strain trials for conditions like IBS, the heterogeneity of the data is massive. The results are just all over the map.
Because of the mixed strains.
That, and the cell study explains exactly why. The study cohorts in these trials consist of a completely unknown ratio of persisters to resistors. If the therapeutic agent you're testing is actively being repelled by the mucosal immune system of half the patients in your trial, the aggregate data is always going to look muddy. We are basically prescribing a biological agent blindly.
I hear you, but let's frame that heterogeneity in a broader medical context. Think about everyday pharmaceuticals, right? If you have a cup of coffee, your reaction to the caffeine depends entirely on your genetics.
Right.
Just because one person is immune to caffeine and can fall asleep right after drinking a double espresso, we don't declare that the biological effect of coffee is a myth. We just recognize that people metabolize it differently.
But coffee isn't a live organism trying to colonize an ecosystem.
It's the same principle with pharmaceuticals, though. If a patient doesn't respond to a specific blood pressure medication because of their underlying genetics, we don't declare the entire class of antihypertensive medications biologically invalid.
Fair point.
We simply recognize that we need personalized diagnostics. In this case, we need that transcriptomic profiling you mentioned to identify the persisters ahead of time rather than completely abandoning the therapy. The science of probiotics isn't broken. Our clinical application of it is just, well, in its infancy.
I am entirely in favor of precision medicine, and I agree that profiling is the ideal future state, but we have to talk about the present state and the present reality of how these are used.
Okay, let's talk about it.
Specifically, we need to address the single most common real-world use case for probiotics, which is repopulating the gut after a course of antibiotics.
Yes, and that is a space where the clinical data is exceptionally strong. When we look at using LGG or Saccharomyces boulardii alongside a course of antibiotics, the number needed to treat, the NNT, to prevent one case of antibiotic-associated diarrhea is roughly 9.
Yeah.
In the medical world, an NNT of 9 is a highly effective clinical intervention.
Stopping acute diarrhea in the short term is one thing, but we have to ask what is happening to the underlying ecosystem over the long term.
What do you mean?
Let's go back to that same cell research group, because they looked specifically at post-antibiotic microbiome delay, and the results were genuinely alarming.
Okay, what did they find?
When you take a broad-spectrum antibiotic, it essentially strips away your native colonization resistance. It's a biological clear-cutting. Your native flora is decimated.
Right, that's why you take the probiotic.
But if you then step in and administer a standard 11-strain empiric probiotic cocktail, those foreign bacteria finally have no competition. The resistors can't resist anymore, so the probiotic strains colonize beautifully.
Right, which is exactly what the patient is trying to achieve. They are repopulating a devastated gut.
But they're repopulating it with the wrong bacteria, and the downstream consequences are severe. Remember, these probiotics aren't altruistic. They are fighting for real estate.
Well, they're occupying the niche so pathogens can't.
True, but those foreign lactobacillus species don't just passively sit there to help the host. They actively secrete antimicrobial factors that chemically suppress the return of the host's native keystone taxa.
Wait, really?
Yes, particularly the order Clostridiales, which are absolutely essential for long-term gut health. By taking that probiotic, the patient locks themselves into a delayed, incomplete microbiome recovery that extends for more than 5 months. During that entire half year, their mucosal diversity remains severely suppressed.
Wait, so the probiotic is essentially acting like a secondary localized antibiotic against the patient's own native microbiome?
Exactly. It's establishing dominance and refusing to let the original tenants back in. In this study, they compared this to patients who did nothing, who just practiced watchful waiting after antibiotics.
And how did they fare?
Those patients recovered their native flora in a matter of weeks. They also looked at patients who received an autologous fecal transplant, meaning they gave them back their own pre-antibiotic stool, and those patients recovered in a matter of days. Giving an empiric probiotic after antibiotics to prevent dysbiosis actually causes prolonged, chemically induced dysbiosis.
That is a staggering finding, I'll admit, but we have to be really careful about drawing a universal conclusion from it.
How so?
That study demonstrated the harm caused by a very specific 11-strain empiric cocktail. We have to question if this prolonged suppression is a universal feature of all probiotics or just a dangerous side effect of poorly designed arbitrary multi-strain mixes.
I think it points to a systemic issue.
But think about it. You mentioned Saccharomyces boulardii earlier for preventing diarrhea. Saccharomyces boulardii is a yeast, not a bacterium.
Right. Because it's a fungus, it doesn't secrete the same bacteriocins that lactobacillus does. It operates via completely different competitive mechanisms like protease secretion and physically binding to pathogenic toxins.
That's true. It is mechanically different.
Right. Because of its fundamental biological differences, it likely does not suppress the return of native bacterial flora in the same chemical manner. We absolutely cannot conflate the ecological harm caused by a clumsy 11-strain bacterial cocktail with the precision application of a targeted yeast.
Well, that suppression you just mentioned from those 11-strain cocktails, that brings up the terrifying reality of what's actually sitting on pharmacy shelves right now.
The supplement aisle. Yes, that clumsy cocktail is exactly what the commercial industry is pushing on an industrial scale. I mean, if you're listening to this, you've probably stood in the supplement aisle looking at a wall of bottles boasting 50 billion, 100 billion, even 500 billion CFUs, colony-forming units.
Oh yeah, the numbers game.
They jam 15 different strains into a single capsule because consumers are conditioned to think that more is better. But arbitrarily combining strains like that is a biological recipe for mutual antagonism.
Because they're competing for the same resources before they even reach the gut.
They are fighting each other. They secrete antimicrobial peptides to neutralize their sister strains right there in the capsule, in the bottle, before it even reaches the human stomach.
Yeah, it's a bit of a free-for-all.
The arms race of megadoses is completely divorced from biological reality. And worse, the quality control in this unregulated space is genuinely terrifying.
You're talking about the contamination cases.
Yes. In 2014, there was a highly publicized, tragic case in Connecticut. A premature infant in a neonatal intensive care unit was given a Solgar probiotic supplement that was marketed to contain beneficial bifidobacterium and lactobacillus.
I remember this case.
But instead of thriving, the infant developed mucormycosis, a devastating, rapid-acting fungal infection in the gastrointestinal tract, and tragically died. When the CDC and FDI investigated, they found that the unopened probiotic bottles in the hospital were heavily contaminated with the Rhizopus oryzea, which is a highly virulent mold.
Wow.
We are giving unregulated, live, metabolically active organisms to vulnerable, immunocompromised populations, assuming they're safe simply because they are marketed as health supplements.
That case is an absolute tragedy, and it highlights a critical, undeniable need for pharmaceutical-grade manufacturing standards. The lack of FDA oversight in the supplement aisle is a massive vulnerability. I completely agree.
It's a glaring loophole.
But the medical and scientific community is already course-correcting based on this exact data. If you look at current clinical prescribing habits, 77% of pediatric probiotic prescriptions rightly favor single-strain formulations, or SSPs.
Okay, moving away from the cocktails.
Exactly. And comprehensive meta-analyses consistently prove that single-strain products are clinically equivalent or very often superior to those arbitrary, antagonistic multi-strain mixes you mentioned. Furthermore, the science shows that the optimal dosing isn't 500 billion CFUs. It's proven to be much lower, right around 15 to 20 billion CFUs, to achieve the desired metabolic effect without overwhelming the system.
So you are agreeing that the current commercial paradigm of live negadoses is fundamentally broken.
I agree the commercial marketing is broken, but the underlying science is already offering a brilliant solution that bypasses these quality control and antagonism issues entirely.
What solution?
It's an emerging concept called the viability paradox, and it leads us directly to the postbiotic alternative.
Postbiotics. Okay.
Right. For decades, the entire scientific community thought these bacteria had to be alive to work. But we now have robust clinical evidence proving that inanimate or heat-killed microorganisms, which are classified as postbiotics, can confer the exact same immunological and physiological benefits without any of the risks of live bacteria.
But how does a dead bacterium provide a biological benefit? You're removing the metabolic output. They can't produce butyrate or ferment fiber if they're dead.
That's true. You lose the metabolic output, but you are relying on the structural components, which are incredibly potent.
The cell walls?
Exactly. When you take a specific, highly characterized strain and you purposefully heat kill it, its cell walls remain structurally intact. These cell walls are made up of incredibly complex molecules, peptidoglycans, teichoic acids, and beta-glucans.
Right.
These are the fundamental structural building blocks of the bacteria. When those inanimate fragments hit the human intestinal epithelium, they act like a lock and key. They interface directly with the host's toll-like receptors on the surface of the immune cells.
So the body's immune system still recognizes the structural signature of the bacteria, even though it's no longer a living threat or a living symbiont.
Exactly. The structural signature alone triggers a profound immune modulation cascade that is often identical to the live bacteria. But by using an inanimate postbiotic, you completely bypass all the viability issues.
Because they aren't alive to begin with.
Right? They are shelf-stable indefinitely. They don't die in stomach acid. They don't engage in mutual antagonism and fight each other in the capsule. And most importantly, returning to your point about safety, there is zero risk of microbiological translocation or devastating mold contamination like in the tragic NICU case you cited.
Okay, I see the appeal.
Postbiotics effectively and elegantly separate the biological benefit from the risks of live bacteria.
The mechanism of toll-like receptor modulation is fascinating, and I entirely accept that postbiotics are remarkably safer, especially for vulnerable or immunocompromised patients.
It's a huge step forward.
It is. But we have to look at what embracing postbiotics actually means for the industry as a whole. I mean, it's a massive philosophical shift. Relying on dead bacteria completely dismantles the World Health Organization's foundational definition of probiotics.
Well, science evolves.
But the WHO explicitly defines them as live microorganisms which, when administered in adequate amounts, confer a health benefit on the host. If the safest and most scientifically effective way to deliver these health benefits is to purposefully kill the bacteria first, it proves that the commercial industry's central marketing premise that you absolutely must consume live, active cultures to be healthy has been scientifically inaccurate for decades.
I wouldn't call it a dismantling of the science, though. I view it as an evolution of the science based on new evidence.
A rather convenient evolution for the manufacturers, perhaps.
Well, as we draw our debate to a close, my core position remains that the clinical benefits of microbiome modulation are irrefutable when we apply the science correctly.
With the right strains, sure.
When specific, highly characterized strains are applied to targeted indications at validated doses such as LGG for pediatric diarrhea, B-longum 35624 for irritable bowel syndrome, or even B-longum BL21 as an adjunct therapy for glycemic control in type 2 diabetes, they absolutely work.
Right.
The solution to the current mess we're in is precision microbial modulation and a strict transition towards single-strain biologics and postbiotics. We shouldn't throw the baby out with the bathwater just because commercial marketing has vastly outpaced scientific rigor.
And my position remains that the empiric, one-size-fits-all probiotic paradigm is biologically broken and often reckless. We cannot ignore the reality of individualized mucosal colonization resistance.
The persisters and resistors?
Right. The discovery that empiric probiotics severely suppress the recovery of native keystone taxa after antibiotic use is a massive red flag. It proves that we are often actively harming patients' microbiomes while under the illusion that we are saving them.
In those specific cocktail use cases, yes.
When you combine that delayed recovery with the mutual antagonism in multi-strain megadoses and the rampant, sometimes lethal contamination risks, it becomes abundantly clear that broad probiotic supplementation is very often an illusion and sometimes a direct biological hazard.
Well, despite our disagreements on the application, we do have a very strong point of convergence today, which is that the global regulatory labyrinth is utterly failing both the science and the consumer.
Oh, completely.
In the United States, the FDA's framework allows for these incredibly vague structure-function claims on packaging, like, supports gut health, which only confuses consumers, while the agency immediately cracks down on targeted, scientifically backed disease claims.
The global inconsistency is just staggering. In the European Union, the EFSA has essentially banned the word probiotic entirely from packaging because their standards for proving health benefits in completely healthy, asymptomatic populations are nearly impossible to meet.
Right, it's the other extreme.
Meanwhile, India is taking a radically different approach. They are currently debating shifting the oversight of high-dose therapeutic nutraceuticals
completely away from food safety authorities and handing them over to pharmaceutical authorities, specifically the CDSCO.
Which makes sense for clinical doses.
That kind of pharmaceutical-grade oversight, mandating strict, good manufacturing practices and rigorous clinical trials before a product hits a shelf, is exactly the kind of structural reform this industry desperately needs to separate the actual science from the snake oil.
It is undeniably a field in massive transition, with the science moving far faster than the regulations. For our audience listening today, if you want to understand where this incredibly complex field is heading next, I highly recommend looking deeper into the source material regarding inanimate postbiotics and the rise of transcriptomic diagnostics to finally identify the persisters and resistors.
Understanding the mechanisms we discussed today really does permanently change how you look at that supplement aisle.
It does, because at the end of the day, restoring the human microbiome isn't like tossing a handful of seeds onto a barren patch of concrete. It requires a profound understanding of the soil, knowing exactly which seed belongs there, and above all, respecting the incredible complexity of the microscopic ecosystem we are trying to heal.